Or a good friends for.
So just for the sake of the recording, we're going to start talking about the different types of relations to make sure that we have like an adequate representation of the ways that relations might be used. So that's where we're at in the meeting. Really haven't discussed a whole lot beyond that. All right, here we go.
Yeah, excellent.
So yeah, sets. You asked, can edges? You mentioned edges directedness. We had initially kind of said that edges were from and to, and therefore, if you wanted to represent sort of a two-way, there's no undirected edge, the way that we have it specified here.
Yeah, but that's pretty common to have undirected edges, edges pointing in one direction, and even edges pointing in both directions. But if we talk not from the arrow view, just from the logical view, yeah, directed and undirected still is a semantic thing. Are these two things somehow just connected, or is there some kind of flow implied?
So would we want to change this so that it seems like this is overly specific then? This edge is defined as if it is a directed edge. So it sounds like we at least want to change this to be, these are the two nodes that are connected. And then you can further specify that it might be from one to another, or it might be bidirectional, or it might be just undirected.
But do we really need a bidirectional edge? Isn't that the same as an undirected edge from this relation standpoint?
Could be. Yeah.
Yeah, that seems the same to me.
Okay.
So we could just add a Boolean directed yes or no, and default is yes and or no.
well then we still need to know which edge is the from and which is the to.
Why not if we call it from and to?
Okay, so this is from and to, and it's just undirected.
Yeah, directed is false and still from and to. I mean, it's technically great if they still have a technical direction, although it's not meant to be a logical direction, but you can still use it for sorting edges.
That's a good point. And otherwise then also like if you have a yeah. In other words, the two ends of the edge are logically distinct from one another using these labels from and to, which could be a helpful distinction down the road. Especially in the cases of like, if you think about how arrows work, when you have an undirected line, then you have those two, you can set what the end point looks like for either end, but you need to know which one is which.
Yeah.
You need to be able to distinguish between the two ends, so to speak.
And another nice question is, what exactly is the edge pointing to? So if it's pointing to another node, may it also point to another relation?
Yeah, we did say that, we said this somewhere that that edges can point to nodes or relations. Yeah, here it is. The from and to arrays contains. Yeah, from and to can be nodes or relations. There it is.
Okay. Then we have a Boolean directed or not. What's also common is some kind of weight on the edges, which could be a double, also optional, and a label is also something, but we could also leave out the label and say that's too visual, that belongs to the arrow. But then I would say a type on the edge is crucial to bring over the RDF land.
Okay. So the type makes more sense to me than a label.
Yeah, I agree. And the type needs to, what is the type? RDF uses a URI, which is the ID system for RDF. So here so this would allow to represent your RDF, but if we want to represent an edge type as another relation carrying more metadata, then we need a new relation type, namely the edge type relation. Which, yeah.
I don't know that I follow that 100%, and that might be something I need help picking up. I'm not sure.
Okay, let's say we have some people and they work at companies. So we have a relation and we now represent the things visually and the relations. So we have John works at Microsoft and Jess works at Apple. And now this works is something that is reused. So both relations just say, yeah, that's the works relation. And now we want a central phrase where we sort of describe the type works, where we say works actually always a directed relation, and you always work at a company, and what's working there is people or robots. All this metadata belonging to the works relation needs to be attached to the work relation somehow. And if in order to attach stuff to things, we need to represent them as relations in our model. It's not visual, so it's not a visual node. So it's a structural relation. So we need a relation type as a thing.
I've gotcha. Okay, so the schema here would be relation, and we might have maybe it has a type too. Well, wouldn't the type be
yeah, the ID and the type is then synonymous. So the type, this might be the label of the type actually. So the type is just edge relation 1, 2, 3, or any ID. We don't care, but how to represent this type in a visual editor, you would say works or works at, or in German, arbeitet bei, if you have multilingual labels. So yeah, and we allow extensions to add more properties, of course.
Right.
But to make this all work, we need to reify the relation type as being more than just a simple string. Yeah. So if we have Jess Apple type works, then here we would need to say ID is works, so that the two things are connected, that we know that. So you have the actual relation, Jess working at Apple.
Yep.
And then you have something
an edge. Yep.
Representing the works itself.
Yeah, this is, so I'm trying to make a, this is the metadata node.
Okay, so we just need to resolve the ID clash now. So the Jess works at Apple has at relation ID 1, 2, 3, 4. And now here we need a different ID.
I had a sum relation 1, 2, 3, 4. Sorry, I know.
Okay. Okay, got it. Sorry. Yeah.
Yeah.
That's.
Or you could even do it this way of like edge relation, just to make it more clear. Metadata. This is the metadata.
Or you could just call it works if you want to, or relation. I mean, any ID. And then
ID, it doesn't matter as long as it's not the same.
And then this ID should be used in the type field of the other relation. That's the link.
Oh, you would go this direction.
Yeah. This is how RDF people would do it, because now stuff is linked.
Because this could describe lots of different edges. So this is
it can and then you sort of have like it's like with class and instance. You have the general class of these relations, these working relations. It's always people working at companies. And then you have the concrete relation. This Jess is working at this Apple company. And
right. So with some of the example of like, started at or whatever, and some date and
no, this would go on the other direction because Jess started working at Apple. Here we just state that started at has a type of date, but we wouldn't give the date here because you would use the exact same metadata blob for Joe working at Microsoft. It's the same.
Gotcha. So the important part is that this is a works type.
Yeah, you could. Yeah.
That's the critical thing.
Yeah, maybe not call it type here, just label, because we already said that this is the type of relation by using the ID on the other edge.
Got it. Okay. Okay, this is helpful. Starting to understand what you're saying. Okay.
And the name, the name is also wrong. Yeah.
I think name is probably not a thing. That should be probably down in the properties array if we have one, or the properties bag. So then here we would use our like extension, property extension type thing.
And maybe state the time from it too, if we need to.
Right.
Or whatever. Yeah.
Yeah, if we wanted to have started at, then
started at and ended at, or
yeah.
So depending on the mechanism we use for property bags, whether we, which we haven't decided yet, but
running into that. We got to decide that. So however we're doing that, then this could be like a, custom slash. But isn't this custom slash works like the same as this? Like aren't the properties that are on this governed by this kind of? Like they're related in some way. Like this property of like started at
yes, but what if we have a custom color? No, color doesn't make sense. Okay, structural. Yeah, I don't know an example where we need custom schema property bag on the edge itself that's not governed by the edge type.
Mm-hmm. Yeah, it feels like the edge type is going to be, yeah. So in some ways, the schema here is custom slash works. But to your point, we're going to want, goodness. So this feels like this needs to be the same as this. Because the label isn't a lot, it isn't it's a logical label, not a view.
Yeah.
Not this works. That would be on the arrow. That wouldn't be described on the edge. This would be on this would be on the arrow node, is to be really clear.
Yeah.
These two things are related, if I'm understanding you correctly.
I'm unsure about the schema link, but I'm sure we need labels because labels are really, really great for debugging.
Mm-hmm.
And
well, it feels like what you're saying is that the edge we need. Okay, let me see if I can. The edge relation might have custom properties on it that would be based on the type of relation it is, but that's this part. Then I'm still not clear on what this is.
You would state, for example, that the to of the edge is always of type company. That's something on the edge type. So, yeah. You would say it's always a company. Works for is always a company. So if you do metadata RDF inference, you could deduce that Apple must be a company.
Mm-hmm.
Yeah, that's semantic web. People love that.
Got it.
And if you just import semantic web data, you want to represent it on the relation side. And in order to be able to do that, you need to represent the relation type and stuff like domain and range they call it from the function. And they
I'm just
also
not sure
store
why. I'm just not sure why it has to be a separate thing. Like, doesn't this
for
say
reuse.
exactly the same things? Doesn't this do exactly the same thing? By saying this relation, this edge relation has the type OCWG edge and also has the type custom works. And it has these properties, right? I don't understand why it has to be a separate.
Yeah, so maybe we could put all this metadata for the edge type
here
in the schema.
Yeah.
Yeah, that
feels like a more natural way based on what we've done with other stuff.
Yeah, I agree.
Okay,
so
I'm gonna leave this here just as like we thought about this and just cross it out for now because we might want to bring it back.
So the type we have up there would not link to an edge relation. It would not to a relation ID, but to a schema.
Well, it doesn't link to anything. We're basically saying if you want to specify the type, this would be, I think this is how we would be communicating it. If you want to specify the type of a relation between two objects, then you add an additional schema to that edge's schemas. And so it can have more than one type. Doesn't have to have just one, which is, that's one of the I guess nice things about it, maybe. And you know that for schemas of at custom works, the from is always a person, like you said, the to is always a company. You could even filter or search the entire set of relations to find all of the relations that have the type custom works. And like from there, find out what all the companies are by aggregating all of the two nodes.
Yeah, I agree.
Yeah, this feels good.
Like also, it fits nicely to the.
Yeah, it feels very analogous with our other schema extension stuff that we still have to figure out exactly how it works. But assuming we can do it over there, we can do it here too.
Yeah.
Cool. Righty. That makes a lot of sense, actually. All right. And then back over to the document, the spec. So we've talked about directed and undirected edges. We talked about being able to specify the type of a relation. I'm going to leave hyper edges alone for a minute and let's go back to sets.
I have a question about edges.
Yeah, I'll go for it, Mike. Yeah, please.
What about ports? So if an edge connects to a specific port on a node, this example, the nodes don't have ports.
So it depends. Either edges cannot connect to ports because edges are logical and ports are visual, or ports are, let's say ports are visual nodes. So we have two blocks A and B and both have a port, south and east. And now our edge simply goes from this port ID to this port ID. So the edge itself doesn't really change at all. It just goes from a visual node to a visual node. And we have two additional relations relating the mother node with the port node.
No, exactly, like I said, probably. That the parent node and the child node. They are
maybe even a special port relation that explicitly states this is linking a normal node to a port, because it's such a common pattern, and if we can explain it, it's easier to reuse it. I mean, this is a very, very good example for all these kinds of edge cases. We can just say, yeah, use a normal edge, relate your object with your port, or we could provide some built-in support for ports.
Help me understand the conceptual ports part. I don't know that I followed I understand the visual ports, which would just be use arrow like or have like a version of arrow that has those properties supported or exposed.
We could so if we have two nodes, example, we have two big nodes and they have a port. We could just say our relation is just relating the big nodes. It's just not even talking about ports.
Exactly.
Or we could say they do relate from port to port, and then we have another relation relating the ports to the nodes. And if you really want to know which node, big node, is logically connected to another big node, then you need to understand ports and edges so that you can actually follow all the logical links.
I got you.
Both are valid. Yeah, and now you need some ports.
Yep, I'm gonna add some ports in here. There we go.
The simplest example that I can think of is in visual programming it. If you have a node that sums two numbers, you have two input ports, A and B, for example.
There we go. Okay, so then conceptually, I think what you were saying is this would have a...
You could just draw either one edge connecting big node 1 to big node 2, or an edge connecting the big node 1 to the port of big node 1, another edge connecting that port to the other port, and a third edge connecting again.
Yeah, I see what you're saying. So this would be like our relation between the two. So these two nodes are connected with one another, but they're also, another relation would be, let's see, these two ports are connected to one another. I'll use the word rel so it's short, but also this port is connected to this.
Yeah,
node.
exactly.
I see. I see. Yeah, it's a lot you have to do for that pattern. That turns out to be pretty.
Both has pros and cons.
Yeah.
So
relation.
Obviously, if we can somehow make the ports relation explicit, then another tool has a chance to understand it and correctly route arrows if things change. So understanding ports is kind of nice.
Yeah, no, I see what you're saying.
So what is a port for us? Obviously, you have two visual things, the big node and the port node. And now we are free how we model the relation. We could just give the big node a ports array. Then we also have captured the relation from the big node to its ports. So make it a first-class citizen in the visual world. Or move it into the purely relation world. And both is valid. We just need to feel what's better. And I don't know.
It's a really good question.
I mean, ports.
Here's the advantage of this. There is a slight difference. There is a slight difference, and it's this. If we had I'll just use this one. Let's call this a port relation real quick. We'll say that this is, we're defining, goodness. Sorry, got this thing going crazy here. No, other way. Well, that's fine too. So this little port is defined, the relationship between this big node and, so from big node 1 to, we'll call this port 1, even though we don't have a number for it or anything. It's not directed. well, I mean, I don't know. I don't know if it's directed or not. I'll have to think about it. But it could, let's say it has like a schema of OCWG / port. Then you could, actually maybe.
Well, the port is a visual node for sure, because it has a position, it is rendered in some way. So there is a place to import stuff.
I'm leaving that alone for a second, and I'm trying to deal with just the conceptual for a second, because I think what Michael said was really interesting of you could actually have a like a schema for it's conceptually, this is a React flow / addition port is like the schema for it. And
you could also add that on the port node itself.
Like here?
Right now you are, no, I mean right now you're editing the port relation, right?
Yes, yeah.
But the port itself, the port is a visual node. And the visual node has property bags and can be extended with custom schemas. So data about the port should maybe be stored on the port. Data about the relation between the port and the big node maybe goes where you are right now.
I mean, I would defer to Michael and other people who are working on like this kind of tool, because this feels this kind of the fact that this port deals with addition feels like something concerning logical and not visual. It feels like something that should be represented by a relation and not in the visual world. But I defer.
Yeah, and how I think of it, the port is, it is also visual, but also conceptual, I think. But just in case of that addition example, the port is just something that has a name, which receives a value, and another port receives a different value, and then the big node does the addition, but it reads its values from the ports.
And
the edges which connected from other nodes which have some value in them and sends them to the ports there, that are relations between the nodes and the ports. The ports themselves probably don't have a lot in them, but I think they could be relations.
I think I understand what you're saying. You're saying that like this thing is the thing that does addition.
Yeah.
And the port is just, it's like input output.
Yeah.
Is that what it is?
Both. Yeah, you can have both 2 inputs, for example, 2 input ports or 1 output port. It depends, really depends on, if I speak for my own tooling, it really depends on what the node does. You can also have 1 input port which has 2 output ports. For example, if you have a node that performs a map on an array, then the input port receives an input value of type array, but those 2 output ports, one of them is the map function that does the mapping for each item in the array, and the other is the output, the result.
Gotcha. How are you currently, how would you want to represent addition? Would you want to split? Would you want the node? So you have an addition node that's an actual node.
Yeah.
That node could have an arbitrary set of input and output ports, and it sounds like, yeah, go ahead.
Let's start with the base case. We have a big node which represents addition, ignoring ports for a second. So we have a big visual node and we have some structural data about it. This is representing addition. So we said in the beginning, we are not splitting visual nodes and relations very Catholic, just what feels right. And we have definitely a visual node. So it seems to me, it makes most sense to just store the additional metadata that this is actually doing addition in some tool, just in a property in that visual node. So to not have to deal with more IDs and linking and stuff, we have one thing, and it's representing a circle, and it's representing addition. And if it's deleted, both things are gone, and they belong together. So it makes sense to just use one object.
Yeah, no, I think you're right.
And if that is right, then if we have ports, then it makes most sense to put stuff in the port nodes instead of in some relation, and only put some things in the relations in the very indirect way if that's really helpful, or really between these two things. And
yeah, it feels like there would be something like here. And you're making the point that a port is like an additional node, visual node as well, that people have to know.
Yeah, the port is rendered visually, so it's a visual node. So
so then
now
this might have 1, 2, 3, 4. Sorry, a port. So this guy has one.
Yeah.
You see what I'm saying? So like this points to that, and it's the other way around, sorry. And this points to that.
Okay, now I would again ask Michael, can a port be both the addition port for one node and at the same time be the subtraction port or output port for another node? Because if a port is always used as just either the input or output and that's it, then we can just put that information into the port and relate the mother node and the port node in a generic way that's not specific to code flow apps, because ports are such a universal concept.
Yeah, in my example, in my case, it's they are not reusable, the ports, but
they're not visual, you said?
They are not
yeah,
reusable.
they are linked, they are really, they are, yeah, not reusable. They are connected to the nodes themselves.
Got it.
I mean, like you have it here. If you select the circle, or you get a blue line, and the markers, they clearly belong to only one object. Ports are not shared among nodes, and that's a very common semantics of ports, which we can sort of capture once and for all and say visual nodes can have ports. Period.
I like that.
And here's
we don't have to deal with the like accidental cascading delete type stuff of like oh well, you know, if you delete this, you should really delete that too.
No, we still have that. We still have that. We can't get rid of that because each port has its own visual representation, which we can't do layout. So we need to have the circle as one visual node and the small port thing as another visual node. The only thing where we are still free how to remodel it is where do we store the relation that port belongs to that node.
Right, this thing. How do we do this piece? Did you have it? Yeah, what's your thought?
We could just have an array on the big node listing the IDs of its ports. That would make the easiest way to delete stuff and so on.
Gotcha. So an array up here.
In the addition node. Yeah, exactly. Yeah.
Well, we already have it. Exactly. So in the addition node, it has input and output ports.
But no, not input ports, output ports, but the generic way. And not in React Flow schema, in the general schema. So the OCWG ports extension allows you to put ports.
I've got you. Okay. So it looks like this. Now you're saying we've added ports to this shape using this internal.
Yeah, yeah. Any shape can have ports, and here are the IDs of the ports, and you already know how to render a visual node. They can have any funny size, shape, whatever you need. But we got you captured. We know what the ports are. And that's a reusable functionality defined in OCWG/ports.
And I think just ports, not input and output split.
Yeah, just ports.
It can be, and the type can be specified in the node.
Oh, I see. Yeah, exactly. Because that would be, it's possible that you could have a port that's not an input or output port, because that doesn't make sense. So you could have, this would need to be something like a schema at React Flow / addition or whatever that says this is an input port.
Exactly.
Or
This
probably more like this, like
Yeah.
or something.
Yeah. Actually, typing is adding a schema.
Yeah, that's cool. And then there may or may not be, you could have, things like if there were, yeah, okay, that makes a lot of sense.
Yeah.
Okay, that feels good. And so then in this case, this is an addition node, but we don't need to specify the ports here. We have we now have lifted that functionality up into an official OCWG extension. And then the schema can take advantage of that. The fact that this is an addition node, it can go look up the ports that it has and then find out which ones are input, which ones are output.
Exactly. Yeah. Very
That's
nice.
cool.
Like
Yeah,
that.
this feels good. Woohoo! Well, I'm glad you brought up the ports thing and we kept digging on that. Yeah, that feels a lot better than this, where we would have like 4 relations just to model a simple 2 shapes with 2 ports each.
Yeah.
And tracking down all these relations would be okay, then in the case where, if we go back to this case, then we no longer need the port relation. We no longer need that port relation. We no longer need, what relations do we need?
We still need these 2 of the edges. Yeah.
Yeah, I think you're right.
Depending on the use case, we need left or right side.
Yep. And then what should this port, I can picture in my mind what big node 1 related to big node 2 looks like. What is the relationship between these 2 guys look like? So it's an edge. And it goes from port 1 to port 2.
Yeah.
And that's it. It's undirected. And it doesn't have anything else. Like, that's it.
Well, if it's part of a code flow editor and the output that the one node did compute is actually routed to the input of the next node, then maybe there is another schema attached to it stating that.
They certainly could, but in terms of like minimal behavior, like this captures the addition nature of the node, like Michael was saying. This is just saying the ports and the shapes are already related down here, so we don't need that. This relation is only saying when big node and big node 1 and 2 are connected to each other, the part that is connected, that connection is taking place through this port, through these 2 ports. That's interesting.
Yeah. And whether that's actually helpful in the context of an application or not is not so clear.
Oh, this is good, because I was thinking about arrow as well. Like the other piece that you would need here is you would actually need an arrow node.
Yeah, true.
And the arrow node can take advantage of the fact that there are ports here for its from and to.
Yeah.
Which is really helpful. Like having those as separate nodes, that's gonna make the layout for the arrow node much simpler.
What I do myself in this case is the edge in my tool. The edge has links to the nodes, but there has a separate property which specifies the port names that are used, that are connected.
So you more or less have both. So the edge knows it's attached to this node and this port.
Yeah, it's duplicate.
I think it's a quite common modeling and helpful too, but has some redundancy.
Yeah.
Yeah, it's not bad. We don't disallow that we just create a shorthand version that allows you to get away with less if you'd like. The other thing is like all of this works even if a purely visual tool leads off all the relations. Like that's one of my concerns is that I think a lot of the purely visual tools don't have a rich internal semantic or taxonomy. And so when they export, they're going to export things that are just having to do with the visual representation, and they're not going to go very far to like representing the underlying semantic relationships. So relations might be empty, is my point, other than things like groups and things that are needed for more visual type stuff. Okay, so this is great. Ports. Cool. We've got a few minutes left. I think the one thing we didn't talk through is around sets, groups, frames, many other things. I think in some ways sets are simpler because they're literally just a list of nodes that can then be extended to we can extend using our property bag extension, our schema extension, but capability to represent all sorts of logical relationships, including groups, frames, groups that are hidden, groups that are visualized. Yeah.
And as a set can already contain as a member another node or another relation, it can already recurse and form a tree.
That's exactly right. Yep. Yep.
And the extension could define whether you actually inherit properties to your members or not. That was a case that Jane brought up.
Yep. Yeah. And hyper edges, I'll leave that to Orion to figure out, since that's one of his favorites.
That is one of my favorites.
I love hyper edges, but there's no mathematical consensus on how to model them, and you can.
Yep, that's definitely one of the challenges.
That's the whole point that that's the whole reason that we're the standards definers. We don't have to have consensus among the entire mathematical community. We just have to have internal consensus. Oh, goodness. Well, this is great, guys. 3 minutes left. Do y'all have anything last minute we want to talk about? I think I'm going to see if I can get some time with Orion, probably early December is my guess of when I'll be able to get together with him. That'll be working on, the ideal would be that we could spend time on some implementation stuff. Max, you had mentioned maybe taking a crack at doing some, like collating all of this information into one place that we could start getting external feedback on.
Yeah, that'd be great.
Yeah, I mean, the existing design decisions document is probably a good start, and then can be turned into more spec-like document.
Mm-hmm. Yeah, I think what I noticed with the design decisions document, which I think is right, is that that's headed in the direction of replacing entirely the thing that we currently have as the spec document, which is fine. Yeah.
They're not connected yet, but I'm coming just from the top to decide, and then, okay, now we do this actually in JSON. Okay, what does it look like then? Because in the beginning, we just decide what are we actually representing at all. I mean, these drawings in TL Draw, that was not always so JSON focused to decide what belongs to what. And yeah, I think it can connect in the end, and maybe I can copy some stuff from the existing spec to add it to one big document.
That's great. Yeah, and it that makes me think that it would be really nice to have visuals, given that we're describing a visual canvas. It would be really nice to have JSON and like a snippet of a visual that here's what that looks like.
Yeah, what I love to do there is to generate a diagram from code and use plant UML. That's a very nice toolkit to decide small graphs.
Yeah.
and
That works for me.
they work fine.
What was the language that you mentioned?
Plant UML.
Oh yeah, okay.
I think
Is
I
that
added
one of the ones
two.
that's supported in GitHub? Like renders
No.
out of GitHub, or is it Mermaid the only one that's supported?
It's only Mermaid is supported natively, and Mermaid is
Whichever
not
one you
very-
would like. Since you're doing the writing, you get to choose.
Yeah, usually I'm not even writing in Markdown. I'm writing in ASCII doc, which is a much richer system. But if I bring that up, then I'm writing everything alone. So maybe I should try to stick to Markdown.
I actually wrote in an ASCII doc before I was converted to Markdown, so I am.
Ooh, the wrong side. What
yeah,
happened?
I'm now a Markdown guy. Don't get me wrong, but I did spend a lot of time in ASCII doc before that. ASCII doc is nice. I have no
Have
problem.
any of you tried a typist?
Typist, TYPUS?
The LaTeX
That's the-
contender,
yeah, exactly.
the new latex.
I've been
I read
enjoying
some blog posts. That guy's the guy behind Typist is probably just awesome.
It's a wild project to try and do.
Yeah.
Righty. I got a drop, so I will see you all next week, and we'll do some async stuff.
Great.
It's gonna be good.
Good.
All right.
All right.
Thanks all.
Yeah, man.
Yo.
See y'all.
Bye.
Bye.
All right.
Are we done? Yes.
Yeah, I think so. Yeah. See you guys.
You, see you guys.
We made
Okay,
it.
bye, Michael.
Bye.
See you next
Bye.
time.
Yes.
See you next time.